Good evening, sir.
Good evening, everyone. Just in 1 minute, we are starting. Let everyone join. Okay, so now I think we can join. Okay, am I audible to you clearly?
Yes, sir.
Okay, Sampath, thank you for informing. Okay, so may I expect that everyone is able to see my screen?
Yes, sir.
Yes, sir.
Okay, so see all these things we have done. We have done these things. Okay, we were doing in last class separation of the substances, including how different substances can be separated out from their mixtures. So, So we'll start from here. Saturated and concentrated also. Okay, separating the components of a mixture. This is what we had to do, and here we had done few of the methods. We had done evaporation, we had done centrifugation also, we had done decantation, sublimation, centrifugation, chromatography, distillation, and fractional distillation are the ones which are left. I'll also be explaining you again. I'll explain you chromatography, centrifugation again, but I think the rest of them are clear.
Sir, actually, I don't think
Anyone
so we
having any
covered
doubt about
sir, actually, I don't think so
yes,
we
what
covered
happened?
this fractional distillation last class.
You have fractional distillation of air.
Sir, I didn't means in the last class. I don't think so we covered that topic.
Okay. Anyways, we'll see all these topics. Okay.
Okay,
Knowledge
sir.
is not dangerous. So see, in this evaporation process, we have seen that this is a method used for separating a volatile component, that is a solvent, from a non-volatile component, that is a solute, by heating the mixture. So examples we have taken like salt and water. Here an example has been taken. Ink is a mixture of dye and water. So if some ink is heated in a dish, so whatever water is there, that water will evaporate out and the dye is left in the dish. Similarly, we can separate a mixture of salt and water or sugar and water by the process of evaporation. So see, you don't have to boil water, you don't have to heat it to 100 degrees Celsius. We just have to heat it slowly so that all the water evaporates out from it. If water evaporates out from it, so the non-volatile means, okay, what do you mean by volatile and non-volatile?
So
Can you explain me the
volatile are the substances which get evaporated easily at low temperature.
okay? Yes, volatile substances, they are the substances which can be evaporated easily, whereas non-volatile substances, they cannot be evaporated easily at normal temperatures. Okay. So if you have a mixture of and solvent and non-volatile solute, well, it can be separated out by heating the mixture. Heat the mixture, you'll be able to separate both of them. Got it? Then we have done centrifugation method. So with the centrifugation method, we have seen a different examples. For example, churning of milk, where by centrifugation of milk, we are able to separate the components of milk, that is butter and butter, cheese, we are able to separate out by the process of churning of milk, which is the process of centrifugation. Got it? So this method of separating denser particles and lighter particles from a mixture by using centrifuging machine. So if you use the centrifuge machine, you can you can separate the denser particles and the lighter particles from them. For example, here if we take a milk by centrifuging milk, if you spin it rapidly, if the cream separates from the milk because cream is less dense than milk. So that is why you will be able to separate out cream from the milk by the process of centrifugation. We also learned that the working of washing machine is also based on the principle of centrifugation. Due to the difference in density of the dirt particles and the difference and the density of water, we are able to separate out the dirt particles from the fabric. By centrifuging the fabric at high speeds, the dirt particles, they are centrifuged, they are removed from the tubes. The decantation process. So decantation can be done in various methods. Either you can use the process of decantation just by keeping one of the container and pouring the contents into some other container by using simple methods. So when I say simple methods, you must use this one. So in simple methods, you are just taking a container. Take a container over here, whatever mixture you are put it. Now take another container. Now pour when the two substances they look to you as separate. First of all, you hold it for some time, which we also call as sedimentation. You let the contents of one substance settle down at the bottom. The ones which are less denser will settle down at the bottom, and the ones which are rarer or less dense, they will be on top. So here you have the dense particles will be at the bottom. Now you pour the contents of one container into another container, and hence you will be able to separate out the conditions. Got it? So for separating by this method, another thing is given. You are given a separating funnel. You can take the help of a separating funnel and then separate out the contents. You see how does the separating funnel work? This is a separating funnel with a stopcock. You can see a stopcock is there. A stopcock is there by which it's just like a tap. So whenever required, you can turn it on or turn it off. So these can be or it can be used for separating two immiscible liquids which have different densities. For example, we are here separating out a mixture of water and oil by the process of this is the use of separating funnel, which we also call as the decantation process. You are taking help of the decantation process over here. So initially, you need to put your stopcock off. You need to put this stopcock, close this stopcock, you can say. So initially we will close this stopcock and then fill the contents, fill this separating funnel with the contents. If you fill the separating funnel with the contents, so the denser particles which are there, they will be towards the bottom, and the lighter particles will remain at the top. So for example, here you have a mixture of water and kerosene. So since kerosene is lighter, so kerosene remains on the top, whereas water is at the bottom. Got it? So here, when you turn on, now just keep it for a few minutes so that you can see both of them clearly. You can see water and kerosene forming two layers separately. Now, if you turn on the stopcock slowly, just slowly turn on the stopcock so that water starts coming out of it. So only water will start to come out, whereas the kerosene will remain on the top. So if you open up the stopcock, all the water comes out. When it's till the kerosene reaches here. So when the kerosene reaches here, you again close this tap. So you have separated out water and kerosene from this mixture. Got it? So next one is okay. So this one also we studied yesterday. Can anyone give me the name of this process? Yes. What is the name of the process?
Sublimation.
Sublimation. Okay. So yesterday we studied this process as the process of sublimation, where we used a mixture of ammonium chloride and common salt. A mixture of ammonium chloride and common salt was taken in a beaker, and an inverted funnel was kept over it. So this is an inverted funnel which has been kept over this beaker or china dish. So this inverted funnel, it completely closes and does not allow any of the ammonium chloride vapors to escape out of it. At the top, we have put a cotton plug so that the vapors of ammonium chloride do not escape. When it's heated, ammonium chloride, it's sublimed directly into the gaseous state. It doesn't enter the liquid state. It directly enters the gaseous state. So when it enters the gaseous state, as it reaches towards the top of the funnel, the top of the funnel or the top of the funnel is cooled, or it's cool as compared with the china dish. So whatever cotton plug or cotton you put over here, you will be getting your ammonium chloride moving through this funnel and reaching over here. Since there is no space for the ammonium chloride vapors to move out, so once you turn it off, if you turn off the fire, so all the ammonium chloride vapors which have evaporated out, they are sticking to the walls of the funnel, and they will solidify as the temperature cools down. So all the vapors will solidify on the inner walls of this separating funnel. Okay. So this method, I think some of you are expecting this method to be done again. What was the name of this process?
Chromatography.
Which process? Yeah, this process is called as chromatography. Chroma means color and graphy means graph. So obtaining the colors of graph is called as chromatography. This specifically method that we are doing is called as paper chromatography. Okay. Apart from paper chromatography, you have highly efficient chromatography techniques other than the paper chromatography. but this is the simplest one to be performed in the laboratory. In this paper chromatography, what happens? A paper is dipped inside a solution, and a blot of the substance which is to be separated out, or whose components are to be separated out, is put as a dot on the paper. So as water rises up the paper, it tries to, as water rises up the paper, it makes the paper wet. So when it rises up and reaches this surface, so when it reaches this point, it dissolves the contents of the substance in it and carries it along with water. Now, since different substances of which it is made up of, so different substances, they are dissolved to different extent, and hence they will be carried on to different levels along with. So along with water, you will find here that different substances will be carried to different heights. So here we observe, we have taken an ink spot. If you put it like this on a chromatography paper, we observe that the different colors of the ink, they separate out by the process of chromatography. Got it? Anyone having any doubt with this method of chromatography?
Sir, can you once show the video of chromatography and centrifugation?
Sir, this chromatography applies only for colors like
Yeah, chromatography applies for those substances which consist of substances of two or more colors. For them only you can use chromatography. If the substance does not, if the substance is made up of more than two colors, then you can separate it by the process of chromatography. If it's made up of different substances, but those different substances are not colored, so you can't use the chromatography technique. Also, the chromatography is based on the principle of solubility. Now, a simple distillation process. See, what is the distillation process? Distillation process, it depends on the boiling point of the substances. The difference in boiling point of the substances is used to separate them by the process of distillation. So, which substances can be separated out by the process of distillation? The substances which have difference in their boiling point, and the difference in boiling point for this process has to be greater than 25 degrees centigrade. So if you have a difference in boiling point to be greater than 25 degrees centigrade, then only those substances can be separated out by the process of distillation. So why we call it as a simple distillation? Can anyone tell why do we call it as a simple distillation? Okay, what is the process? Have you understood? Have you ever heard about distilled water?
Yes, sir.
So, what do you mean by distilled water?
Purest form of water.
It is a form of water. So, which form of water is distilled water?
Sir, it is purest water.
Yes, distilled water is purest water. And see, how do we obtain this? To obtain distilled water, distilled water is purest form of water. So, for this one, for the purest form of water, the process is very simple. You take water in a beaker. Any water you can take in a beaker, and generally take it if it is pure, or any water can be taken. So if you heat this, I'm heating this water from here. So the water which is in this, it will evaporate out. The water will try to escape out, it will try to evaporate out. Use some other vessel. using some other vessel, just cover this vessel, and from here you can attach a pipe which will carry the vapors away from this. So here what will happen? The water vapors, they will rise up, pass through this, condense, and they will get collected over here in another beaker. So this water which we have collected, this is distilled water. Since water is boiling at 100 degrees centigrade, so this only those substances will be there which have boiling points to be 100 degrees centigrade. Any substance which is a boiling point greater than 100 degrees Celsius will not be there in this water. Okay. So this process is called as process of distillation. By the process of distillation, we can separate out different substances which have a difference in their boiling point, and the difference in boiling point is greater than 25 degrees centigrade. So here boiling point should differ by minimum of 25 degrees centigrade, not less than this. If it differs by a temperature less than 25 degrees centigrade, let's say there are two substances whose boiling points are very close. Suppose one of them has a boiling point of 90, the other one has a boiling point of 98. So for separating such substances, we cannot use the method of the simple distillation. For them, we'll be using fractional distillation method to separate out those different components. Got it? Yes, anyone having any doubts?
No doubt, sir.
Okay. We have that. The next is fractional distillation. See, the fractional distillation will be used only for those stars which have a very small difference in their body. So for this, we have to use a fractionating column. The fractionating for the fractionating column, it will have different temperatures at different heights. At the bottommost level, it will have a very high temperature. And as one moves up on this fractionating column, so the water level rises. Okay, in the fractionating column, the water level, the temperature will decrease. So only those substances which will have a low melting point will travel up. Those which have a high melting point, they cannot travel up and they will be separated at the bottom point. A technique, see here, it is used for separating a mixture of two or more miscible liquids whose difference in boiling points is less than 25 Kelvin or less than 25 degrees. So, can anyone name me a few places where we use this process of fractional distillation?
Sir, separating petrol from crude oil.
Okay, separating petrol from crude oil is one where we use fractional distillation. Not only petrol, we separate all the components from the crude oil. We will separate all the components from the crude oil at by the process of fractional distillation. Any other
So
place where we
separating
utilize this?
Petroleum components.
Petroleum.
So can we separate petroleum components like petrol and other things using fractional
Okay.
distillation?
Okay. Just 1 minute. Okay. Let me show you how we use at different temperatures. We use a fractionating column over there. And in the fractionating column, at different heights, different temperatures are maintained. So initially, all the substances are boiled from air, and as the vapors rise up, so initially here you will have just I'm giving as an example. Suppose here the temperatures are maintained at 100 degrees centigrade. Here the temperatures are maintained to be 60 degrees centigrade. Here the temperatures are maintained to be, let's say, 40 degrees centigrade. So in this way, at here, let's say you have a temperature of 80 degrees centigrade. Now see, if a substance has a boiling point of, or let's say if a substance has a boiling point of 70 degrees centigrade. Okay. So when the vapors are rising up, so this substance cannot cross this 80 centigrade line. This will be below this only. At 70 degrees centigrade, it will start converting from gaseous state to the liquid state. So when it gets converted to the liquid state, it will be captured over there only and separated out. Got it? Yeah, is your doubt clear? Okay, let me show you. Let me show you uh, how the petroleum components are separated out. We'll see separation of petroleum components. So here we will see how can we separate out the different components of petroleum. See, so just let me give the picture of it. Okay, see this image. You can see any of the image over here. This is here, I think. Just okay. See. Here you are given a picture of a fractional distillating column. This is a fractional distillating column. First, the petroleum products, they are heated to very high temperatures. You have the petroleum products, they are heated to very high temperatures over here. The oil is heated in a furnace. This is the first step. So when oil enters this fractionating column, here you have all the oil in the vapor state. Okay. See, now the temperature, how the temperatures are maintained. At the bottom, the temperature is maintained at 400 degrees Celsius. Here the temperature is maintained at 300 degrees centigrade. Here the temperature is maintained at 300, 200, 150, 20. So you have this temperature grading of the fractionating column. At every point, you maintain a different temperature. So when the vapors are allowed from here, these vapors, the vapors which are hot enough, they travel upward. When they reach at the region of 370 degrees centigrade. So at this temperature, the fuel oil, whatever fuel oil is there, that fuel oil is separated out. It condenses into the liquid state and can be separated out. Then you have diesel. So for the diesel is obtained at a temperature of 300 degrees centigrade. So you can say that for diesel, the boiling point is 300 degrees centigrade. So when water enters 300 degrees, or when the gas enters 300 degrees centigrade, all the diesel which is in this, so that diesel starts melting and or starts converting to the liquid state, and it is collected over here. So in the same way, all the substances which are collected at each temperature level. Yes. So who had doubt about this? Yes. Who had doubt about this? So is it clear to everyone how we
Yes, sir.
can separate out the substances by the process of fractional distillation? In the same way, we can also separate out by the process of fractional distillation. We can separate out different components of air. Like we can separate air mostly consists of nitrogen. So by this process, we'll be able to separate out nitrogen, oxygen, argon, carbon dioxide. So all the gases can be separated out from air. That is again by compressing, collecting the air, and then again changing the air into air is already gas. So first free uh, you pass it through fractionating column at different temperatures. So first you cool your air and then pass it at different temperatures. Okay. So that it can be collected over. Okay, that's so we were here at the fractional
Sir, can
distillation.
you share this PPT
Next is
in the WhatsApp?
separation. Okay, you want this one to be
Yes, sir.
shared in the WhatsApp, right? Okay, I'll try to share it. I'll try and share.
Okay, sir.
Fine. Okay, so here fractional distillation we have done. The next we were discussing about separation of components of air. So the components of air, they can be separated out. See, first the air is collected, it is compressed and cooled by increasing pressure and decreasing temperature. So all the air is cooled, then you have the liquid air. Liquid air is allowed to warm slowly, so that slowly and slowly different substances can be obtained. So oxygen will be obtained as minus 183 degrees centigrade. Argon will be obtained as minus 186 degree, whereas nitrogen will be obtained as minus 196. We also did this process of crystallization. So See, crystallization, I explained you yesterday that crystallization is the process in which crystals are formed and those crystals can be separated out. So what are crystals? Crystallization is the process of obtaining pure solid in the form of crystals from its solution.
Sir, can you tell how it is? Means how are the crystals formed once again?
What happened?
Sir, can you means revise this topic?
Crystallization, it is the process of obtaining a pure solid in the form of crystals from its solution. So here you
So
have impure, yes.
how do we obtain the crystals?
Okay, so for this, see, you have an impure copper sulfate. So you take your impure copper sulfate and form a saturated solution of. Once you have made a saturated solution of impure copper sulfate, then allow it to heat at high temperature. So if it is heated at high temperature, it will form a saturated solution, or you can say a super saturated solution of copper sulfate will be formed. So it is heated up to the crystallization point, and after that, it is allowed to cool. So it is allowed to cool when copper sulfate cools down. Pure copper sulfate crystals are obtained. Pure crystals of copper sulfate, they are obtained.
Okay, sir.
Got it? So I think now we are clear with everything. And these notes, they contain all of them. They contain all the things which were required. For example, the difference between mixture and compounds is also given to you. Mixtures are substances which are formed by mixing two substances. They can be present in any ratio. That is a mixture. Got it? Anyone having any doubts?
No doubt, sir.
Okay.
Sir,
So we have completed this chapter. Yes.
sir, do you have any PPTs like this for motion and matter in our surroundings?
Okay. You want for matter around us and for
Motion
that one
also.
also, motion also. Okay. I'll
Yeah.
try and arrange. Okay. I'll
Okay,
try
sir.
if I have. I'll arrange. Okay. Anyone else? Okay. So bye everyone. We'll see you all again.
Thank you, sir. Bye.
Bye, sir.
Thank you, sir.